This video is over section 4.1, properties of radicals. And one of the essential questions we're going to be looking at here is how do you multiply and divide square roots? Before we get into this, we kind of want to talk about the basics that we already know. And part of that is, what is a square root? And so a square root is one of two equal factors of a number. So what are the two equal factors that multiply to give us 16? Well, that would be 4 and 4. So the square root of 16 is 4. What are the two equal factors that multiply to give us 64? 8 and 8. So our answer is just 8. If there was a negative in front of one of these, for example, if this had been the negative square root of 225, that means we're going to do the negative. It means negative 1 times whatever the square root of 225 is, which is 15. We're going to look at how to simplify square roots that are not perfect squares in this lesson. But if you have a perfect square, this is what you do. You just go ahead and give the answer when you know what it is. So before we get into that, I want to talk about a few things. Let's look at this. Is the square root of 36 plus the square root of 64 equal to the square root of 36 plus 64? And let's explore. What's the square root of 36? 6. And the square root of 64 is 8. So 6 plus 8 is 14. When we do this problem, we're going to do the square root. We're going to add first. So 36 plus 64 is 100. And the square root of 100 is 10. Are those two things equal? And the answer is no. We can see plainly that 14 and 10 are not equal. So in general, a plus b is not equal to the square root of a plus b. Now let's talk about multiplication. Is the square root of 4 times the square root of 9 equal to the square root of 4 times 9? So the square root of 4 is 2 times the square root of 9 is 3. That gives us 6. When we do this side of the problem, we want to go ahead and multiply what's under the radical first. So 4 times 9 is 36, and the square root of 36 is 6. And those two things are equal. So yes, in general, the square root of a times the square root of b is equal to the square root of a times b. Now, what we did there was not enough to prove that it's true all the time, but it is true. And so that's one of the rules we're going to be using today. When we look at subtraction, we're going to test the same idea. What's the square root of 64? Whoop, is 8. Let's go back. The square root of 64 is 8 minus the square root of 36, which is 6, gives us 2. But the square root of, but on this one, we want to subtract first. So that's the square root of 28, which is not 2. So this one's not. The square root of a minus the square root of b is not equal to the square root of a minus b. The last one we're going to test is division. The square root of 100 divided by the square root of 4. Well, the square root of 100 is 10 divided by, and the square root of 4 is 2. So that gives us 5. When we do this one, we do the division inside first. So 100 divided by 4 is 25. And the square root of 25 is 5. So this is another rule that we're going to be using. The square root of a divided by the square root of b is equal to the square root of a divided by b. So this rule right here is the product property of squares. This is the one that we were looking at first that says the square root of 9 times 5 is equal to the square root of 9 times the square root of 5. This is helpful because the square root of 9 is a perfect square. And the square root of 9 is 3. Sorry, the square root of 9 is a perfect square. So the square root of 9 is 3 times the square root of 5. Gives us 3 times the square root of 5. This is the simplified version of the square root of 45. When we look at these numbers, here we're going to simplify the square root of 108. When we do this, we look at this number under here, and 108 has plenty of factors. But what we want to know is, of those factors, does it have any factors that are perfect squares? And 36 is a factor of 108, and it's a perfect square. 108 is the same as 36 times 3. So what we do is we split it up using our rule we just learned to say the square root of 36 times the square root of 3 using that product property. The square root of 36 is 6, and the square root of 3 is not a whole number, so we leave it 6 times the square root of 3. On this next one, we have the square root of 9 times x cubed. Well, since 9 is a perfect square, we're going to start out by leaving that just the square root of 9. But x cubed is not. But we know that x squared is a perfect square, and x squared times x is x cubed. So we break it up into the square root of x squared times the square root of x. The square root of this is 3. The square root of this is x. And we leave that the square root of x. So we get 3x times the square root of x. And we're going to practice this quite a bit. These are just our first two examples. So let's talk a little bit about perfect squares, since I said we're looking for perfect square factors. Perfect squares are the numbers that we get when we multiply another number by itself. For example, 1 times 1 is 1, 2 times 2 is 4, 9, 16, and so on. All of those numbers we're getting, these numbers in blue, are perfect squares. But when we talk about variables, sometimes that's a little bit more confusing. So we want to be sure we can identify perfect squares that are variables. X times x is x squared. So x squared is a perfect square. X squared times x squared is x to the 4th. So x to the 4th is a perfect square. X to the 3rd times x to the 3rd is x to the 6th. Remember, when you're multiplying this, our exponent rule says to add our exponents. We're not multiplying the exponents there. X to the 4th times x to the 4th is x to the 8th. This one gives us x to the 10th, x to the 12th, and x to the 14th. So if we look at that, we see, look at all of our exponents. And what do we notice? All of our perfect square variables have even exponents. So we know if we see a variable with an even exponent, it's a perfect square. For example, if I have x to the 23rd, that's not going to be a perfect square. But if I have x to the 22nd, 22 is even, so I know that it is. And when I'm looking to find it, look back at this pattern. When x to the 10th was a perfect square, the square root of it was x to the 5th. The square root of x to the 8th is 4, and the square root of x to the 6th is x to the 3rd. So the square root of a variable is that same variable with half as much exponent. So the square root of x to the 22nd is x to the 11th, because we know x to the 11th times x to the 11th would give us x to the 22nd. Now that we've identified those, we can do some practice using those skills. Let's simplify these expressions. We've got the square root of 24. So when we think about our perfect squares, we really skip over the 1, but we look at these other perfect squares, and we want to say which of these numbers, what's the biggest one that's a factor of 24? If I look through my list, I know 4 is a factor of 24, and that's the largest one. So I'm going to say 24 is like saying 4 times 6. So I'm going to say that's the square root of 4 times the square root of 6. When we do this process, one of the numbers has to be a perfect square. We are not just looking for any factor. We're only looking for factors that are perfect squares. So the square root of 4 is 2. So we're going to leave this 2 times the square root of 6. Here we have negative the square root of 80. So we're going to look at our list and look for numbers that are factors of 80. 4 is a factor of 80. But so is 16. 16 is going to be our biggest one. So I'm going to use 16 if I see it. I'm going to leave that negative out here. I'm going to say 80 is 16 times 5. So we're going to break this up into the square root of 16 times the square root of 5. So that gives me negative 4 times the square root of 5. Now we get into the ones with variables. We want to be careful. I'm going to break it up into the number part and the variable part. My number part is a perfect square, so if I want to go ahead and take that square root, I can. That's going to be 7. X cubed is not a perfect square, but I know that x cubed is x squared times x. So I'm going to break it up into the square root of x squared times the square root of x. So I get 7x times the square root of x. We'll do the same thing here with our 75, but 75 this time is not a perfect square. So I go back to my list and say 1 is not a factor, 4 is not, 9 is not, 16 is not, 25 is. So I'm going to break this up and say it's 25 times 3. And then into the 5th, that's an odd, so it's not a perfect square, but into the 4th is. So I'm going to say into the 4th times n. So we break this up and we say the square root of 25 times the square root of 3 times the square root of n to the 4th times the square root of n. And then we're going to take the square roots. These two are perfect squares, so I'll do them together. That's going to be 5n squared times the square root of 3 times n, which is just 3n. We don't ever want to end up with multiple radicals in our answer, so that's why we put the 3 and the n together. And I'm going to go ahead and stop this video here, and then I'll make another one for the next step.